Okay guys, so as we continue on talking about what we have been talking about, we're finally to the last type of function that we need to learn how to take the derivative of. So this will be the very last thing that we talk about as far as finding a derivative, and then from here on out after today we're going to start talking about where we use these things, all these derivatives, to actually apply to real life scenarios. So the last type of function that we need to talk about is a logarithmic function. Now, I know it's probably been a little while since you've talked about logarithms, so just as a quick reminder, a logarithm is always written in this form where we have log and then there's a base number of some sort, and then there is a number that's written in a slightly larger font. And what all logarithms are saying is, if I were to raise this number to a certain power, what would I have to raise the base number to get this number right here? So in this case, we say it is log base 3 of 9, we would say that that is 2. And as long as the numbers are nice and easy for us to deal with and understand, it's really not that big of a deal as far as what the answer to a logarithm is. The problem is most logarithms aren't that easy to solve. Like if I had log base 4 of 213, I have no idea how many times I multiply 4 by itself to get 213. And our calculator will do that work for us, and luckily for us, that's not something that you actually have to do on the AP exam, but just realize that that is what a logarithm is. Now, one special type of logarithm that we have is log base e. We talked about e yesterday, and we know what e is. We call it the natural number. And so the ln is actually the natural logarithm is what it's called, and it gets used so often in real life that rather than writing log base e all the time, we write ln and it means the same thing. So when you see ln, that is the same thing as a logarithm. It's just a special kind of logarithm that we use often. And it's actually the only type of logarithm that shows up on the AP exam. You learned a bunch of properties about logarithms last year, where you talked about how to change a logarithm if we have two logarithms and we can multiply stuff together. None of those rules we actually have to remember. In fact, the only two things we have to remember about the natural logarithm we're looking at is that the ln of 1 is always 0 and the ln of e is always 1. Anything else, if you have to find the natural logarithm of anything else, you either just leave it, like the ln of 5, or you'll have to put it into the calculator if it's on the calculator active section of the test. But by and large, ln's, we just look at them and we say, okay, I'm going to have to do something with it rather than just evaluate it. And so the first thing we need to talk about is what the derivative of the ln of x is. Just like the other ones we've been talking about recently, the derivative of the ln of x, it's just a memorization. And in this case, the derivative of ln of x is 1 divided by x. And it's always that. It's always 1 divided by x. It's a pretty easy one to remember because, again, not that hard. The derivative of ln of x is 1 over x. If I'm taking the derivative of the ln of a function, in other words, I am looking to apply the chain rule, the rules still apply. I would guess you would be able to figure this out pretty quickly as far as what the derivative is for the ln of some function. Like if I had the ln of 5x, what I would do to take that derivative is I would say that is going to be 1 over the function on the inside of the logarithm, which in this case is 5x. Then we would multiply that by the derivative of 5x, which is 5. A slightly simpler way to write that if you wanted to is you could say, all right, I'm just going to put the derivative on the top and the original function on the bottom, because really that's all that's happening here. I've got 5 over 1 times 1 over 5x, and when we multiply fractions, it's top times top and bottom times bottom, so I get 5 over 5x, which would be that derivative. Okay? So if I wanted to find the derivative of something like this, logarithms mix into functions like anything else where we just take the derivative one term at a time. So I go dy dx is equal to the ln of x is 1 over x. And then we learned before the derivative of 4e to the x is just 4e to the x. And that is our derivative. That's what we have there. Again, logarithms mixed in with other things. I still just take the derivative like I normally do. if I've got chain rules and cosines and sines and things mixed together, we still take the derivative the same way. I take the derivative of the ln of 5x squared, that is 1 over 5x squared, multiplied by 10x, because that's the derivative of 5x squared, plus, now I take the derivative of the cosine like I normally would. That's negative 3 sine of 2x, and then I multiply that by 2, and that's my derivative. Again, works exactly the same in a function as it normally does. The chain rule and the product rule still work the same way. So if I have the ln of 6x times sine of x, the derivative of that would be 1 over whatever we're taking the logarithm of, so that's 6x times the sine of x. Then we multiply that by the derivative of 6x times the sine of x, which would be a product rule. So first function multiplied by the derivative of the second, plus the second function times the derivative of the first. And that's what that derivative would be. Now, hopefully by now you're starting to see that these derivatives all work very similarly. As long as we have like the basic derivative memorized, then we can apply the chain rule, and we can apply the product rule, and we can apply the quotient rule, and they all still work the same, even though they look more complicated. As long as we kind of break it down into easier steps, we're totally fine. So if I had a problem like this, last one we're going to look at, these two things are multiplying together. So the derivative of the two things multiplying together, we use the product rule. First function times the derivative of the second function, so you get cosine of x, plus the second function multiplied by the derivative of the first. So I get 1 over x squared minus 3, because that's what the ln starts as. Then we multiply that by the derivative of the function that is on the inside of the natural logarithm. Again, these are fairly easy to look at. They're not hard to understand. In fact, the only mistake that we often see in these is this. Like if I see the ln of the sine of x, people often forget that this is the ln of the sine of x, and again, they want to try and make it a product rule. By now, hopefully you've seen that that is not a product rule. Instead, the derivative of that would just be 1 over the sine of x multiplied by the derivative of the sine of x, which is cosine of x. So hopefully that makes sense when it comes to logarithms, especially just the ln. We don't need to worry about the other ones because they are not on the AP test. There is a way to find the derivative, and it's not that much more difficult, but it's not something that you have to worry about if that's something that concerns you. Anyway, if you have any other questions about this or anything else that we've been talking about, please come on in and I can help you with those.